Welcome, everybody, to our session, Visualizing Your Audience, which is, of course, part of Data Echo Culture. We're very, very pleased that you can join us. My name is Dr. Sara Diamond. I'm the president, I'm the president emerita of OCAD University, and I'm also the director of the Visual Analytics Lab at OCAD University. I'd like to begin with our Indigenous greeting, and I will read it now. Although we meet today on a virtual platform, I would like to take a moment to acknowledge the importance of the lands which we each call home. From coast to coast to coast in Canada, we acknowledge the ancestral and unceded territory of the Inuit, Métis, and First Nations people that call this land home. For example, in Toronto, where I am currently located, we are in the traditional territories of the Mississauga of the Credit, the Haudenosaunee, the Anishinaabe, and the Huron-Wendat, but also in a city that is a major gathering place for Indigenous people from all over Canada, including the Métis and the Inuit. The 10 First Nations of Montreal, Quebec, where I know many are gathering from, include the Cree, the Nipmuc, Naskapi, Algonquin, Ontagnis, the Abnaki, the Mohawk, the Atacamawa, the Huron, and the Malasite. And Montreal is home to a large Inuit community. We acknowledge these people and their lands to reaffirm our commitment and responsibility in improving relationships between nations and our own understanding of local Indigenous peoples and their cultures. Please join me to acknowledge the values, perspectives, languages, and cultures that can guide and inspire us, the role of Indigenous people as guardians and stewards of the lands, and to consider how we are and can each in our own way able to move forward in a spirit of reconciliation and collaboration. So a few things about today. We have live transcription for the session. Please select your language, French or English, by clicking on the options at the bottom of your Zoom window. You can also join the conversation in social media using the hashtag #DataEchoCulture. The session is recorded and will be retransmitted. So if you do not want to appear on the recording, please turn off your camera. So I'm very excited now to introduce our speakers. I'm going to give you a little bit of their biography, and then we'll go speaker by speaker. And at the end of both presentations, we'll have a chance for Q&A and conversation. One thing that's very important is you can ask a question in the chat at any moment. My colleague Emerita from Synapse is tracking the chat, as am I with one eye. And we'll come back to your questions, so you don't have to wait till the end of the Q&A. So our speakers. So Dr. Anna Jofre is professor at SUNY Polytechnic. She obtained her PhD in physics from the University of Toronto and did her postdoctoral work at the National Institute of Standards and Technology in Gaithersburg, Maryland, and taught and undertook research at University of North Carolina in Charlotte for 6 years before transitioning her career towards the arts. She completed an MFA at OCAD University in Toronto and then worked as a research fellow in the Visual Analytics Lab at OCAD University for her postdoctoral research and at the Institute for Pure and Applied Mathematics and Culture Analytics at UCLA in Los Angeles, California. Her publications and conference presentations cover a very wide range of intellectual interests, from physics to critical theory, and she has exhibited her artwork internationally. She undertakes figurative sculpture, interactive new media, internet art and web design, human-computer interaction, and data visualization. And she is currently an assistant professor in creative arts and technology at SUNY Polytechnic in Utica, New York. Rittika Basu just defended her thesis at OCAD University successfully, and she is a storyteller, artist, learner, and workaholic. She believes good design is a service product that solves problems, involves lifestyle, and enhances user satisfaction through innovation and optimistic intervention. She has worked at the Walt Disney Studios, Toshiba, Total SA, Canadian Heritage, Myant Inc., and Visual Analytics in our lab at OCADU. Shunrong is a graduate student, also just defended successfully, and also a research assistant at OCAD University. As a multidisciplinary artist and designer, she specializes in hand craftsmanship, and digital visuals. She holds a BFA degree in jewelry and metalsmithing at Rhode Island School of Design, and she currently, as I said, defended her thesis in interdisciplinary art, media, and design at OCAD University. So we're having a little bit of an OCAD show today, and I'm very happy to welcome our first presenter, Anna Jofre. Over to you, Anna.
Thank you. So I'm going to share my screen, and I want to start with giving a little overview of some methods and types of visualizations that I think are useful for visualizing demographics. So I'm going to go ahead and start with, So a little bit of motivation, why visualize data? For that, I'm showing you Anscombe's quartet, which I think is a most compelling demonstration of the power of visualization. So Anscombe's quartet is a set of four data sets that actually have nearly identical descriptive statistics. In other words, they have the same mean, they have the same variance, they have the same linear regression line, they have the same R-squared. So all within 2 decimal points. All of these descriptive statistics are the same, but clearly they're very different data sets. And without visualization, you really have to dig through a lot of math to see how they're different. With visualization, you can see immediately that they are completely different. So a little bit more about how this works with visualization. So data visualization leverages our visual processing ability. So human beings are gifted with this ability to process visual information in parallel. And we use our pre-attentive processing in order to interpret visual information. So the goal of information design is to leverage this to help humans process information as efficiently as possible. And visualization allows us to make use of this pre-attentive processing mechanism in our brains. So just as an example, I've got these two columns here. Pre-attentive processing is your automatic instinctive visual processing. So you can see in this example, we have a red circle among blue circles. It doesn't even take a second to find the red circle, right? It's immediate, it's instinctive. On the other hand, attentive processing is the type of processing that we use to read and to analyze information. So it's slow, deliberate, single task. So in this example, if I ask you to find the red circle in this diagram, it takes a little while, right? You have to go through and look at the shapes individually. It doesn't pop out. So the goal of information design is to try to make the important information pop out like the red circle in the left diagram. Okay, so first let's go over some data, a few words about what kinds of data you find. So data visualization involves data. Obviously, you can divide data into 2 types. You've got qualitative data, which is descriptive, and quantitative data, which is numerical. And that can be further divided, right? Your qualitative data can either be nominal or ordinal. Nominal, it's categorical. Ordinal means that it can be arranged in order or rank. On the quantitative side, you can have continuous or discrete, right? So continuous is data that's measured on a continuous scale, like temperature, length, height. Discrete is data that is countable, exists only in whole numbers. So when we're looking at audience data, we are primarily interested, and I'm just going to focus in here on nominal data, right? We're interested in categories, demographic categories, for example, gender, age groups, income brackets, education, etc. And discrete data, right? We're counting the number of people. So Another thing that might be of interest for audience data is geographical data, which if we have time, we'll get into a little bit of visualizations of those at the end. So what I'm going to do here in this talk is I'm going to do a case study, and I'm going to look at the data that the Visual Analytics Lab they did some really nice work where they created the Canadian Cultural Diversity Dashboard, and they will go into detail about what they did with that. They had this huge data set from Canada's Department of Canadian Heritage, and because it's such a huge data set, they created this big interactive dashboard. So what I'm going to do is I'm just going to take a really tiny subset of this data, and I'm going to show you a few things you can do. And my goal is to just provide some basic tips, tools, and vocabulary for working with this type of data. And I want to demonstrate simple but useful visualizations that help you break down this type of data. So everything I'm going to show you here are so-called quick and dirty things that you can do on Excel. You can just grab the data, and when you work with this type of data, the first thing you want to do is put it in a spreadsheet program like Excel and just start playing around with it. And playing around with it, the most useful way to play around with a set of data, I would argue, is visualizing it, right? So again, I'm just looking at a subset of this data, a very tiny subset, okay? So this data set is huge. I'm looking at a very, very tiny bit. I'm interested in, so the subset I'm looking at is reading habits in print. How many people read books, for example? And so right here, I've got a bar graph. So the first demonstration, the first visualization I want to show you are bar graphs. And so bar graphs are very functional. They're not the best looking, they're not the prettiest, but I would argue that they are, when you're making comparisons, they're the most useful. Again, you pay attention to the idea of pre-attentive processing. So I've got the percentage of the population here on the vertical axis, and each category is labeled right here along the horizontal axis. And you can tell right away immediately that the largest category, unfortunately, is the category of people that have not read a book in the past year, at least in print. So these are reading habits of books in print. And so you can make bar graphs, you can turn it over. Some people prefer having them as columns along the horizontal. So again, same idea. This might be easier to read for some people. But what's nice about bar graphs is you can very quickly compare different categories by looking at the length of the graphs or the length of the bars. So one thing, if you want your data to be a little more playful and to connect more with people, you can use a pictogram. And with pictograms, what you have is you have each symbol represents some quantity. So right here we have each little figure represents 1% of the population. And so pictograms are nice. It's essentially the same thing as a bar graph, but what's nice about them is there's more of a connection, and you're using a visual metaphor here, which a lot of people like. So sometimes when you're doing outreach, it's nice to have visual metaphors. People connect to that faster. Okay, so if you want to subdivide your categories, so here I've got my categories of how many people read books, right? So one book a year, one book every 6 months, one book every 3 months, one book a month, one book a week, no books in the past year. But I want to divide that up into other categories. So one quick way to do that is to use a stacked bar graph. And so right here is we take our bar, and using color, we divide it up into the various categories. And then we have a legend right here on the right. And so this allows you to see not only the total amounts, but how those total amounts break down. And with stacked bar graphs, sometimes, so again, you can do it horizontal, you can do it like along the vertical with the bar along the vertical. So sometimes it's easier to see stacks when there's fewer categories. So right here, I've broken it down by male and female, and you can pretty quickly see that women read more books than men in most categories, except for maybe this one. So, so those are the stacked bar graphs. Another way to subdivide categories in a bar graph is by using a clustered bar graph. So in a clustered bar graph, you have each of your categories is a cluster of bars, and then you can break down each category with one bar for each category. So right here, we've got our categories: one book a week, one book a month, one book every 3 months, one book every 6 months, one book a year. And then we've divided it up into age groups, where orange is the 15 to 24 years age groups. And so the clustered bar graph is nice when you have a lot of categories like this, because you can quite quickly pick out. I can see very quickly that the 15 to 24 year category reads more than the others. And that's probably because that age group is still in school. But we don't know that, so just a speculation. So that's a clustered bar graph. Now, of course, we have many demographic categories. And one quick way to look at two categories at once, if you want to break it down further, you can combine stacked and clustered bar graphs. So right here, what I've done is...
Wow, this is well done.
I've got, oh, thank you. And this is just, you can do this on Excel. It's just like I said, this is all quick and dirty things you can do on Excel to try to wrangle your data before you make something more sophisticated, like what the people at the Visual Analytics Lab are going to show you. So here we've got 2 categories. We've got age and gender, right? And what I did is I clustered the gender and then stacked the age. And you can do it the other way around too. But it just kind of allows you to very quickly look at the breakdown along 2 categories immediately. And again, we can see that the women tend to read more, and we can see the bright orange is the 15 to 24 year age group, and those are in all genders the most avid readers. Again, probably because they're in school, my guess. So, okay, so now I'm going to move on to other types of charts. So that's a bar graph. And I love the bar graph because it allows you to have all this flexibility to start subdividing data into more categories. But I want to talk about other types of charts you could use. So a bubble chart maps the data onto the area of a circle. So you've seen these where the size of the circle is proportional to the quantity. So specifically the area of the circle is proportional to the quantity that is being graphed. So bubble charts for this type of data right here, it's not, you can see probably the bar chart works a little better. Bubble charts are more useful when there's a lot of data points. So if you have too many bars that it gets hard to see, bubble charts are more useful when you have lots of data points, or also when there's a big difference in scale between the data points, because then bar charts become hard when there's a difference in scale, because you have one big one, one tiny one, it gets hard to compare. Areas get easier to compare when you have big differences in scale. So I just threw in an example from a visualization blog of a bubble chart, of when it's useful to use a bubble chart, when you have a lot of data, and also when the scale varies a little more. So then you can make those quick comparisons. So a pie chart. So pie charts are really popular because they're very aesthetically appealing. And this is one thing, as humans, circles really appeal to us as humans. That's just universally, circles are aesthetically appealing. So we have, so people like to use pie charts. I do have some words of warning about pie charts, though. I think they get difficult to read if you have more than 6 subdivisions. So right here we've got 6, and I think that's at about the limit of readability. I think more than that, it just starts getting hard to read. Pie charts are useful when you want to make comparisons in proportionality. If you want to very quickly see who has the biggest piece of the pie, who has the smallest. It's a little harder, as you can see, compared to a bar graph, it's a little harder to compare exact numbers with a pie chart. Pie charts are more useful for proportions. And I think pie charts are most effective when you have fewer things. So if you just want to make a really quick comparison, so right here we have the population that reads at least 1 book a month. Really quickly, you can see women tend to be more likely to read 1 book a month than men. So with smaller, again, you only have 2 here. So pie charts are useful for quick comparisons like that. A variation on the pie chart is the donut chart. Donut charts look very pretty. I'm not a huge fan of donut charts in terms of readability because I think that by obscuring the center part, it takes a little longer to interpret. It's just my opinion. Again, donut charts, I think, are most useful when you have fewer components because you can make those quick comparisons. Another type of data visualization that allows you to compare proportionalities is the tree map. So a tree map, you have a rectangle and you divide it up by your components. So a tree map allows us to pretty quickly see that the none category is the biggest category out of all these categories that we have, unfortunately. So tree maps also have a nice aesthetic appeal, and they're great for comparisons when you want to look at proportions. You want to see which one's bigger or smaller. Tree maps are nice when you have a lot of data, and tree maps are also nice when you have a really big range in the scale of the data because it can get dramatic, right? Okay, so how are we doing for time?
I think you're okay. If you've got maybe another 4 or 5 minutes, can you?
Yes, perfect.
Great.
Okay, good. I just wanted to make sure I wasn't going over. So now I want to talk a little bit about how to map geographical data. And so the most standard way that we look at geographical data is the Chloroplast map. And there are some problems with the Chloroplast map. And this is exemplified by US election maps, where you might have heard people say, but land doesn't vote, right? And so that's referring to the fact that Chloroplast maps tend to bias geographical areas that are bigger. So for example, when we look at the 2016 presidential election map, Hillary Clinton actually won the popular vote by about almost 4 million, maybe 5, something like that. I don't remember the exact number, but she won the popular vote by a few million, right? But you wouldn't know it by looking at this Chloroplast map because the way that it shades in the areas depends on land mass. And so there's ways that people work around this, and this is by creating cartograms. And of course, this isn't anything that you can create on Excel, but I just want to show you sort of different ways. There's lots of different ways that people create cartograms. One way was featured on this blog, Flowing Data, where you can divide up, so you can distort the map, divide it up into these little hexagonal shapes, and each little shape is proportional to some population amount. And then you create your states using these little hexagonal shapes. So this helps. And of course, there's lots of different ways to create cartograms. So I want to show you, this one was created for the 2012 electoral college votes. And this just distorts the map according to population. So you can see that these smaller, more populous states look bigger on the map. And this is a much more sophisticated version, where this one is actually divided up at the county level. And again, you have the distortion according to population. So you have these really small counties like Los Angeles County, which actually has a bigger population than a few states. It's stretched out pretty big. And then these low density states are compressed. And so you've got a comparison here, where in the traditional Chloroplast view, it looks mostly red. You can see that if we look at population, the cartogram better reflects what's going on with the population. So another way to plot data on a map is this graduated symbol map, where you have symbols that represent the quantity you want to map. One limitation in this is the size of the symbol relative to the geographical area you want to represent. So even though it doesn't allow for as much distortion as the Chloroplast map, because your data is directly mapped onto size, sometimes the overlap can get a little tricky. And finally, dot distribution maps. So dot distribution maps, these are one of my favorite types of mapping techniques. It's just very simple, right? So in this example, we have US public libraries. So one dot for every, I don't remember, I think it's every few dozen libraries. It might be every one dot for every library. I don't remember. I have to look it up again. And so right here, right, you can immediately get a sense of the density of a population. And you can use color to, if you had more than one thing that you wanted to put on the map, you can use color for that. And I could actually find a quick example of that if you want in the questions later. I think that's it for me though, for now. I'll go back to that if you want to talk more about it. So in summary, things to think about. Number one, an effective visualization works with our perception, not against it. And so that's one thing a designer wants to keep in mind. Understand what cognitive task you want your audience to do, right? What do you want them to compare proportions? Do you want them to exactly compare quantities? And what visual queries does the graphic, what is it intended to support? So with a design task, you might want to start with asking yourself, well, what's the visual task the audience is going to do with this visualization, and then design around that, support that. So ask yourself, what's the best chart for the data? And often, of course, with big data sets and complicated data sets, you need a combination of charts to compose a full data story. It's never just one or two charts. And you have to think about how those support each other. And I think our next speakers are going to talk in a lot more detail about how combinations of charts can support each other. And finally, ask yourself, are you prioritizing aesthetics over readability? So sometimes the better looking charts aren't the ones that exhibit the data more clearly. So for example, bar graphs, not super glamorous, but very good at conveying information. Okay, so that's
Great.
it for me. Thank you.
And that was a really, really fantastic overview, basics, intro to data visualization. And I wanted to just pick up on why the maps are so important in the current context, because many cultural organizations, have made this foray online, and the audiences who are consuming their culture in the pandemic context are very different than many of the audiences that they had pre-pandemic. And they're more globally distributed, which is one of the positive gains of the pandemic, even if revenues are significantly down. So the ability to actually use the kind of cartographic strategies to look at audience distribution and change over time. You use dots, but there's also heat maps that, show a really intensive kind of concentration. Thank you very much for showing us the maps, because we don't always use those particular tools when we're thinking about, analyzing our audiences. And thank you very much for the overview. We're going to come back. And now it's a great pleasure. And just a reminder, as Eric has reminded all of the audience in the chat, fire your questions into the chat. We'll come back to them at the end. And it's a great pleasure now for me to hand over the podium, the virtual podium, to Rittika and Shunrong.
Thank you, Sara. I will just share my screen, and we're just sharing our project.
And just to let you know, Anna, we're going to come back to a question I was going to ask, which are, what are the software tools that you recommend? And we'll ask these two as well, but we won't do that now. Come back to that. Thank you.
Okay, can you see my screen?
Yes, take it away.
Yes.
Great.
Okay. Good afternoon, everyone. We, Rittika and Shunrong, the students of OCAD University, would be presenting the data storytelling and visualization project for the Canadian Heritage Cultural Sector. Next slide. Okay. The Canadian Cultural Diversity Dashboard is an interactive online data visualization dashboard designed to elicit insights regarding diversity in the consumption and creation of cultural expressions in Canada. Our goals was to effectively represent diversity and inclusion data analysis into agencies to address diverse stakeholders, from equity-seeking groups to policy analysts, companies implementing diversity strategies. We wanted that the intended user could interact with particular points of the visualization to reveal additional details and background information relevant to the main theme. Our audience included the Canadian population ranging from various age groups, geographic location, educational qualifications, immigration status, linguistic background, as well as from variant race, disability, and gender. Each demographic segment is analyzed according to cultural consumption and creative expression across a breadth of disciplines, from literary, visuals to performing arts.
So we also applied a strategy of using a mix of narrative visualization and infographics techniques, because we aim to respond to the needs of our collaborators and the larger cultural community. So the narrative visualizations can structure the data to tell stories from its representation, and research has shown that narrative visualizations can bridge the explanatory and explorative visualizations. On the other hand, infographics are used to suggest meanings that are not evident in the data in a different way to emphasize the values. And the extracted key insights from the infographic can help the users, especially those without the visualization knowledge, to capture and understand the data. We also use metaphors to propel the audience's insights into our data story. So it functions as the bridge to interpret the data or the data context. For example, we used infographic metaphors to frame the visualizations, situating them within a creative medium. We also used pictograms or symbols within graphs in order to correlate numbers with their context to promote the user's engagement into our data stories. So now we will just present some of our data visualization works for this project. And we are speaking as the designers to talk about how we responded to different subjects and how we made visual choices accordingly. We are also more than happy to answer any questions that you might have then. So the first one we want to talk about is the tree map. So as Anna just said, tree maps can display the hierarchical data as a set of nested rectangles with subcategory rectangles inside, and the displaying quantities for each category by the area size. So it functions as that, so it's often used for comparisons, hierarchy, part to whole, distribution, and proportions. Here shows some example of the tree maps. And in our project, this is an example of the tree map that we used here in this project. So the visualization presents two demographic factors that are gender and year of immigration in relation to movie watching practices on digital devices. So we used the tree map here because it clearly compares the proportional data of individuals who watched movie on device by the two sets of demographic data. And also it's a metaphor of the web pages on computer, which is corresponding to the subject of movie on device.
We have another example of the tree map diagram that distributes the population according to their family income to help us understand the reading habit of these families during the period of a year. Here, a book is used as the visual metaphor and the bookmark pictogram is displaying the legends.
And the next one we want to talk about is the donut chart. So it is functionally identical to a pie chart except for the blank space inside that can be used to display information, and it has the ability to support multiple statistics at once. It's often used for comparisons, proportions, and part to a whole. So as an example, this visualization compares the frequency of radio listening habits reported by both immigrants and non-immigrants. And because of the subject of listening to radio, we created a radio visual display to quickly present our subject. The two donut charts fit well in the radio metaphor, giving the audience a straightforward idea of proportional distribution of the data by these two groups of population. And also in this chart, when hovering on the different colors, which represent different frequencies, we can see the corresponding numbers and legends showing up, which is an interactive function.
Following, we have a sunburst diagram that is used to visualize hierarchical data depicted by concentric circles with sliced outer rings. The angle of each slice is either divided equally under its parent node or can be made proportional to a value. Several functions would include comparisons, hierarchy, and parts to a whole. Here, the sunburst diagram is used to compare the population of immigrants and non-immigrants who attends live performance and assessing the frequency of their attendance. Here, two passport pictograms are used as visual metaphors. Next, we would talk about the chord diagram, that is a graphical method of visualizing the interrelationships between entities. The data is arranged radially around a circle with the relationships between the points drawn as arcs, as you can see, connecting the data together. Functions would include to compare, correlate, and determining relationships. Here we have an example that helps us to compare the population proportions among the immigrants and non-immigrants with respect to their reading habit. Hence, a book pictogram has been used as the metaphor to convey the sense of the reading activity. Next is the radial column chart that uses a grid of concentric circles to plot bars on. Each circle on the graph represents a value on a scale, while the bar are used for each category. Functions are majorly comparisons. Here we present the radial tree that presents the distributing number of people engaged in various creative mediums segregated as per their mother tongue in Canada. Example, English, French, or any other language. The data levels on bars displaying only the highest values of the set from the 6 main linguistic categories. Iconography such as musical notes, gallery icons have been used as visual metaphors.
And following is the pictorial chart. So the pictorial charts use relative sizes or repetitions of the same icon, picture, or symbol to show the comparison. Typically, the icons represent the data's subject or category, and its functions include comparisons and distribution. So in this example of pictorial chart, the data indicates the proportion of the population going to movie theaters. So we used the metaphor of cinema seat as an icon to represent the numerical data in an engaging way. The icon is used to allow the users to read and interpret the data more easily. And at the same time, the colors add a level of gender differentiation between attendees. So the blue represents the self-identified males, and the red represents self-identified females. And here comes the Chloroplast map. So this type of map displays divided geographical areas or regions that are colored, shaded, or patterned in relation to a data variable, such as population density or per capita income. And it's often used for comparisons, distribution, locations, and patterns. And as an example, this visualization exhibits combination of Chloroplast map and pie chart. Since the demographic factor presented in this visualization is the province of residence in Canada, so the Chloroplast map is the best choice to display such geographic data by using color progression. As you can see here, it's from light blue to dark blue to indicate the population who listen to music. And on top of this map, the pie charts are overlaid to compare the proportions of those who used electronic devices or conventional devices. And here comes the violin plot. So a violin plot is used to visualize the distribution of the data and its probability density. Typically, but not always, the violin plots will include a marker for the median of the data and a box indicating the inequalitable range, as in the standard box plots. Its functions include comparisons, distribution, patterns, and ranges. So in our project, this visualization presents a demographic factor of citizenship status in relation to conventional or digital TV watching practices. Because of the subject, we use the metaphor of a TV screen as a repository to contain the violin plot visualization, as well as the two donut charts on the right side, which presents the key insights. The violin plot represents and compares the population who watched conventional TV and those who watched online TV using two different colors. The population who watched conventional TV are represented in blue dots, and those who watched online TV are represented in red dots. So from left to right on the screen, each shape of the violin element indicates a citizenship status, such as the group of Canadian citizens by birth only.
Finally, we would be talking about the alluvial diagram that is a type of flow diagram often used to display trends over time and phases. Variables are assigned to vertical axes that are parallel. Values are represented with blocks on each axis. The height of a block represents the size of the cluster. Functions would include comparisons, correlations, distributions, proportions to determine trend over time, as well as finding processes and methods. Here we have the alluvial chart that displays trend over time about the attendance of Canadian population in live performances, represented by the left vertical blocks, streaming into their immigration status, represented by the right vertical blocks. Finally, we would like to talk about two sources where we derived our inspiration in the creation of the visualizations. The first is the DataVis project created by Ferdio, which is a leading infographic and data visualization agency specialized in transforming data and information into captivating visuals. Secondly, we have the Data Visualization Catalog, which is a project developed by the designer Servirino Rebecca to create a library of different information visualization types. Rebecca is an alumnus of the University of the Arts London and currently is practicing design and researching on data visualizations. We thank you all for your time.
Yep, thank you, and we welcome any questions.
Great, thank you. Thank you very much, Rittika and Shunrong. That was quite the tour through the complexity that visualizations can manage in terms of data. And great to, again, return to this strategy that we chose to use, which is really mixing infographics with and metaphors with data visualization strategies. So there are questions from our audience, and I'm going to start with you, Anna. People would love to know, and thanks Rittika and Shunrong for providing the references at the end. This video will be available at the end of the conference for people and they can find it, but you might want to put those into the chat so everybody would have those from your footnotes, from your end references. And Anna, for you, what are some of the basic tools that people can use to kind of get their chops up in terms of data visualization?
Well, I think, as I mentioned in the talk, I think you can do a lot with just Excel or Google Sheets, just to get started, right? Just to do the quick and dirty comparisons, just to see what stands out, what's interesting. Now, of course, you're not going to get the beautiful visuals with that. Those don't offer nearly any of the range that we just saw in the last presentation. So if you want to go a little further than Excel or Google Sheets, I also recommend Tableau. Now, Tableau is very expensive, unfortunately, if you want to buy the desktop version. However, there is a version called Tableau Public, which is free. Now, the catch to that is that you have to save your data in the cloud. But it at least lets you start out and experiment. So those are some that I would recommend to just sort of start playing around with. Tableau has a little bit of a learning curve, but it's not so bad. And if you like doing web things, if you like JavaScript, there's the D3 library, which is nice too. But that gets a little more complicated because that gets into coding, and you have to already have your data charted out before you put it up. Now, as far as mapping, there's lots of nice, easy to use geographical software sets. There's Mapbox is one that's pretty easy. So I was just looking it up here, and somehow, okay, here we go. Maybe I can put a link here. in the chat. Oh, I lost you guys. Exit minimal view. Okay. So there's Mapbox, and there's also another software called Carto that I haven't used a whole lot, but I know people use it for mapping applications.
Yeah. And from one of our participants, Harsh Panchal, ArcGIS. So we use, at OCAD, we use a lot of City Engine and Esri software, which it's a learning curve, but there's a lot of workshops online to use it. You do need a license for it, whereas some of the resources that Anna has described are, they're open source and they're available. And I know one of our strategies has been to kind of do, a remix from different kinds of mapping and software in order to be able to make comprehensive maps with kind of deep analytics engaged with them. One of the things that might be helpful, Anna, if you could start, and then I'll ask Shunrong and Rittika to address this, is you're designers, like you build this stuff. Take us through what you need to hear from a user, from a client, from a partner, when they want you to build a visualization. What do you want to know from them, and what you need from them in terms of, for example, access to data types, but to really work effectively with user-centric design? Do you want to start, Anna?
Sure. I think the first question is really who is the audience and who is this for? Who's going to be reading the visualization? And that would be the first question. And then, of course, the second question is what, in order of importance, what are the most important points you want to make with this data? What story do you want to tell with this data? First of all, and in order of importance, what are the conclusions that you want people to draw from this data? And of course, as far as what I would need everything, all of the data, the spreadsheets. That would be most useful. I mean, it's hard to work with a partial set.
Mm-hmm.
What are the different kinds of data, though, that you're used to, like sources? So you talked about CSV. Talk a little bit about how the data comes to you, and talk a little bit about cleaning data. I have some comments about the second project. Once you finish, that might be helpful for people.
Yeah, so that's true. Data in the wild actually is not, does not look the same way as data in a workshop, right? Data in the wild is usually really messy. And so there is that work to do with cleaning data. And I don't know, I guess in this hypothetical situation, I don't know if the data is already cleaned or not. Ideally, you need to organize the data and clean it up before you can start visualizing. As far as data format, I find that CSV is easiest to work with because that is most transferable to other. You can throw it into an Excel, you can throw it into a Google Doc, you can use R pretty easily with it, and D3 as well, and you can very quickly transform it into JSON if you need to. So yeah, CSV is the most intuitive to work with, and so that's what I would like to have my data in ideally, and that's what I like to use. Yeah, just because you don't need to do any. It's very intuitive to just throw a CSV file into a spreadsheet and look at it.
Maybe you could find a good example that describes what CSV is and toss it into our chat for people.
Yes. Yes.
Yeah.
Sorry.
So a comment I would make is in working with the heritage data, one of the challenges that we had was that in some categories, we really wanted to, and heritage really wanted us to represent very small numbers at the same time as knowing that those numbers were not necessarily representative of a trend, but they represented important margins. For example, in language types that people spoke at home or spoke, and some of the other data that was from Indigenous communities where data collection methods have gotten more sophisticated now and are often in community, but when this data was collected by Stats Canada, those methods were not necessarily used. So it was an interesting challenge in thinking about how to effectively, represent that data. And I think, I don't know, Rittika or Shunrong, if you want to talk a little bit about how you managed that problem of trying to represent large quantities of data, but also showing small data sets in a meaningful way. If one of you'd like to jump in.
Mm-hmm.
So okay, I'm gonna add my experience. So in terms of showing the data, like a vast data, what I did, I segregated it into two visualizations. Like to suppose, for example, to show the highest numbers, I created one sunburst diagram, as well as created another sunburst diagram to show the lowest examples. And the user can hover and go, because it's an interactive platform, the user can choose to see what they want to see. So they can as well as have a view at the highest as well as the lowest with hovering icons if they want to read about the explanation as well as the references.
Great. That was exactly the answer. That's perfect. We do have a question from the audience. How many indicators do you propose to have in a dashboard to get a good picture? Shunrong, do you want to take this one? So how many indicators, what's the upper limit that you think of as a designer, but also how many do you need to get a good indicator? We were certainly struggling with this with the heritage data.
Yes, sure. So for us, like the data set is super large and it's very inclusive. So we have the challenge of include a lot of all the groups of people depending on the demographic factor into our data. So we need to, so for me, the indicator, also I have something to ask. So for the indicator, is that something like the key insights or like the indicator of the legend? Maybe
So
I need a little bit clarification.
Yeah, that's right. So no, that's perfect. So we always, we would deal with 5 to 6 factors at the maximum, essentially in the dashboard. So and that can, when you're dealing with multi-factor data, again, you may have many more factors. So sometimes you need to have different representations and different ways of representing that. And if you think back to what was shown oft on the left side, you would see more simple graphs framed as an infographic, and then you'd see the more complex data visualization. So we are at the end. There's a couple of things I need to tell you. A short question will appear at the end of a session for a quick evaluation of this particular session. So please, we really encourage you to participate in it. I believe it's up on your screen now. And we also need to share with you a bit of what's coming up next. The next events include data sharing with whom and why. You need to, and that's an open panel, and then you need to register also, but there are open spots for remodeling with data and also what to look for in ticketing data. So thank you very, very much for joining us today. It was a pleasure to share the work with you, and please enjoy the rest of the conference, and we'll see you later on.